Every team in the room has been handed the same impossible belief: capable, compliant, and offline resilient. I want to show you today that three things aren't in conflict. They are the same architectural decision made once. This device is in airplane mode. It has been since I walked. I haven't touched the Wi-Fi settings. Keep that in back of your mind. I am bringing in the prototype called EdgeMind, a clinical AI assistant that runs frontier class language model and full MCP control plane entirely on phone. No server, no cloud, no data leaving the device. Regulation is no longer a preference. India DP Act is an act in force, no longer pending. GDPR has enforcement teeth. And if you are in the healthcare or finance, you will have sector mandates stacked on top of those. The compliance requirement isn't store data carefully. It's don't let it leave the jurisdiction at all and prove every automated decision is auditable. That's the data requirement flow, not a policy one. Here is what the default agentic stack does. It serializes your prompt, which may contain the patient name, account number, a field report, ships it to a cloud endpoint, and hopes the DPA never asks where it went. There are three costs to this: token spent per query, that's quantifiable; round trip latency, that's measurable; and then there is one that kills production deployments. It fails over completely when network can't be trusted. A ward nurse doing medication in the basement, a field analyst in oil terminal without signal, a defense system that can't wait for the TCP handshake. None of them have time for a cloud round trip. And for all of them, the data leaving the device isn't technical inconvenience. It's compliance breach. What if the compliance answer and the resilience answer were same thing? MCP's real value at the edge isn't the tune calling. It's that the protocol becomes the single choke point where you decide which model runs, which tools permitted, and which governance rule applies, all in one local pass before any data has chance to leave. Trace the architecture. There are 5 Kotlin files doing all of this. The view model builds a tool called a typed struct, a tool ID, a parameter map. The MCP client wraps it with a scoped capability token and calls the server. Not over a socket, not over a network. The transport is a coroutine dispatch. The server is a class in the same process. We kept the MCP protocol and deleted the network. The server runs the security pipeline, guard model, then IAM, then routing. The result comes back as sealed tool result. The whole thing, security gate, governance decision, inference call, audit, happens in single coroutine on device before a single byte has touched the air. The capability half. 5.3 mini, quantized to INT4, running on Snapdragon NPU via Executor CH. Frontier class intelligence, no API key, no cloud bill. Zero egress makes the DP and GDPR a structural guarantee. Privacy isn't a checkbox in a policy document. It's an architecture property. There is no code path that sends data anywhere. So how does one decision enforce security, governance, and auditing simultaneously? That's the control plane. Before I show you the control plane in detail, I want to spend few minutes on why Executor is doing the heavy lifting here. Because this is the part that's genuinely novel, and it's the reason that this architecture is feasible at all. PyTorch native export. Torch.export captures the computation graph directly from PyTorch. No format conversion. No separate runtime. int4 plus static memory, group size -128, int4, quantization takes 5.3 mini from 14 gigabytes to 2. That's what gets fit in phone. Qualcomm HTTP delegation. The QNN partioner quotes the quantized ops directly to HTTP. Qualcomm fixed function NPU. That's much more better performant than the CPU path. On-device LoRa training. This is what no other mobile runtime can do. Executor has a training API. Rank 8 LoRa adapters fine-tune locally on the device. The adapter is saved to the disk in the same .pte format the inference engine already loads. Training and inference share the same runtime. No data ever leaves the device to train the model. Means the model improves over time without ever creating a privacy liability. No other framework, Onyx runtime, TF Lite, MLC gives you all 4 simultaneously. PyTorch native export, Qualcomm HTP, Int4, and on-device training. That combination is what makes the architecture possible. That combination is what makes the architecture described on the next 3 slides actually possible. I want to be precise about exactly where the line is between what you just saw working and what's next. Technical audiences trust the person who draws this line themselves. In-process MCP with full protocol semantics, working. Two-gate security, working. These are known bounded gaps, not unknown risks. Every one of them has a clear engineering path. The architecture you've seen today works now. The roadmap items make it production hardened. We'll dive into the control plane details in part 2. Thank you.